So let's find out that the momentum part of it.
Okay.
So what do we do?
Well, that's all going to be the same.
Okay, so yeah, so this is going to be the same. So our energy equation is going to be that. What about for our momentum? Our momentum equation.
Energy of one, the small one still has to equal the energy of the second one.
Yeah.
But
Well, so we go like this. Your momentum is going to be your mass times velocity.
Right.
And so we kind of do the same thing that we did last time. You have your mass times velocity equals mass times velocity plus mass times velocity. So, this is going to be your small block, big block, small block, big block, initial and final. So initially, this has a mass and the small one has a velocity. Initially, does this big one have a velocity?
No.
So that just cancels out. In the final, does the small block have a velocity?
No.
Okay, so that cancels out. So here we have our small m times our initial velocity initial. That is equal to our big M times our velocity final.
Right.
Cool. So then when we use our energy equation, that's going to be 1/2 mv squared. This is going to be your initial velocity, not that one. These are different initials.
What's that?
These are going to be different initial velocities. This one is going to be equal to that one. Because this is after the collision.
Right.
So here's the block, and then this one's going to come forward at a certain velocity. This is where we start our energy equation. This is where this comes into play.
Okay.
Is the velocity final of the big block.
So
it's like a 2-step, 3-step process. You have to go from one, take the numbers that you get, and put them into the other equation, and then you start over again. Like you reset the clock back to initial. Everything goes back to initial. Then you find the final velocity or the final mass or acceleration or whatever. Then that becomes your initial. Then you put that into another equation.
So that's the velocity of 2 final.
Yes, perfect. And we don't have any other potential or spring energies. And that is equal to your 1/2 mv squared. This is going to be your final velocity, this one up here.
And that m is 2.
Yeah. This is mass 2, and then plus mass 2 times g times h. Once again, these masses will cancel out. That's nice. Leaving us with 1/2 v squared is equal to 1/2 v squared plus g times h. This is initial and final. This is just solving for your v final, which this v final becomes our v initial in this one, because we reset the clock, everything goes back to initial when we move these equations forward. So this becomes our v initial, so you have 1/2 little m times your initial velocity, which is going to be the initial velocity of this block right here. This is the velocity of the little block, this one right here. All over big M. The big problem with these ones is we have to keep everything straight. Like make sure that we don't lose sight of what is what. And that can be kind of difficult at times. That is squared. And that is equal to 1/2 v. What is your orbital velocity, your final velocity? Do you remember the equation?
What's that?
Do you remember the orbital equation for final velocity?
Times g square root.
Cool. So this is going to be the square root of r times g squared. So then the square roots just cancel out. You have the square root of r times g. So you have your v squared. This is your v. The square roots will cancel out. Plus gravity times your h. And what is your h?
2r.
Cool.
So if you times that whole thing by 2, is that 2g 4r?
So which one?
Times them all by 2.
Yeah, or this one will be, you'll times that over, so that's going to be rg plus 4rg. So that will get us 5rg. If you times this 2 across.
Yeah.
Then I'm just gonna come up here, okay? So here we have little mass times the velocity that the little mass was going over the big mass, the mass of the big block, squared, is equal to 5rg.